My name, for those that don't know me, my name is Mariano Martinez Peck. I work at Instantiations. I am the BAST platform team leader. But I am very technical. I have a technical background, so I'm still doing software engineering activities as time allows. And today is more about sharing what we do internally at Instantiations to develop the BAS platform. And the idea is that hopefully I might be able to share some technique, tips, tools, standards that you might be able to use yourself. Probably I won't have the time to get into how we do each part of what I want to show, so it's mostly about what we do. But if anyone is interested in details about how we actually do some of the things I show, you can always feel free to get to me, and I can try to answer the best as possible. Okay, so first I will start with a very quick vast overview, because for those that don't know, the platform is to give you a very quick idea about the size of the system and how complex it is, so that you know more or less what we are managing and developing, right? And then we will basically go a little bit on the different activities that we do with BAST, like coding, which is obviously a big section, testing, then how we build the BAST platform, and then documentation, and finally a generic conclusion with, of course, a Q&A at the end. So, as I said, as a quick introduction, VAST is not only the Smalltalk language, but of course we have things like the virtual machine, which is another big section of the product. We have a lot of internal tests of multiple types, as I will explain later. We have a lot of builds that scripts to build the products, and for many CI related things. We have installers for both Windows and Linux. We have documentation, migration guide, and many other things. So the thing is that when you think about BAST, it's just not the language, it's the whole thing that's surrounded. And now to give you a quick introduction to the first three, let's say the Smalltalk language, the virtual machine, and the test, I wanted to give you some quick numbers. But of course, as someone said before, Smalltalk is just not the language. As someone said, we also have the IDE, we have a lot of external libraries or frameworks, we have the UI components, a version control system, a lot of tooling around it. So again, it's not just the language. There are all these things that we need to also develop and manage. And to give you some numbers about Smalltalk itself, we have in VAST around 1,400 applications, which in other dialects is the equivalent to packages. We manage around 13,000 classes, around 200,000 methods, and that means more or less a little bit more than 1 million lines of code. Then again, if you now go to the VM is also composed of a lot of different aspects, which I won't go into the details, but we have the interpreter, we have the memory manager and the garbage collection, we have the just-in-time compiler and polymorphic inline cache, we have Unicode support, OS process, and many other sub-modules. And if we take a look to our source code, you will notice that most of the virtual machine is written in C. That's why you see, I don't know, 138,000 lines of code. Then we have some C or C++, some C++, some Rust, mostly for the Unicode support. We have a little bit of assembly. So there are many technologies, but again, this is around 200,000 lines of code for the VM. We have tests for the VM as well. And then, if we now go to the test, as I will explain later, we have multiple types of tests, but just the unit test, we have a test suite of around 20,000 unit tests, which means another 100,000 lines of code. So that means more or less that just with Smalltalk, the VM, and the test, we have around 1.5 million lines of code. So that requires quite some challenges for instantiations to maintain and evolve the product and have the quality that our customers deserve. So now I will get started into the different stages. And as I said, around 2019 or 2018, somewhere around that, we kind of have an internal discussion and we defined what we like to call it the VASTIM coding standards, which is basically a set of standards and tooling and patterns that we like to follow on the VAST code in order to improve the quality of our code. Of course, as you can imagine, we cannot retrofit this into 1.5 million lines of code. So we are doing this mostly to the new code, or we also take the opportunity when we are dealing with old code, like let's say we are doing a refactor or a modification, we try to reapply these new standards. So now I will start with some of these practices, standards, or tooling which are related to coding. The first one, which I think it's one that is extremely important, in my opinion, it's the difference between private and public methods. Maybe in other dialects it's not much of importance, but for us it's critical because if a customer is modifying a private method, then they're more or less on their own. But if we at instantiation need to be extra careful when we change public methods because we don't want to break backward compatibility just because. So it's really important for us to differentiate this because we want to give our customers an easy upgrade path. Sometimes we need to do changes to public methods. So when that happens, there is an entry in what we call the migration guide that will help our customers to move up. I will talk more about that, but the general summary from this point is that we need to find a balance between the necessary evolution of the product, but also with the business reality. So we want to evolve, but we don't want to break existing customers. So that's the balance that we try to find. Then we also try to unify our formatting. So it happened that there's no best way to format Smalltalk code. I'm pretty sure that if we all discuss, we will all prefer different things. So what we did is to stick to the default for instantiations code. So that way we all use the same format. Our customers start to get used to at least see a unified format. And there are some side effects, like it's easier to browse changes because you can avoid browsing changes that are actually formatting changes or things like that. Those are minor details. But the whole idea is to have a unified formatting layout. Another one important is we like to have nice comments, at least for public methods. If a private method needed, we would do it, but for public method, we will try to do it always. We like to include a brief description of the method, description of the argument, the answer, exceptions that may be raised in that method, and examples. We put examples as much as possible, and that has a bonus point, which is very nice, is that we have tests that parse the methods, extract the examples, and run the examples. So by running our test, we know that all of the examples of the comments work, which is nice. Then, while method comments are great, sometimes they don't give the big picture of a class or of an application. So we also have we do class comments and applications comments. The class comments is more about the purpose of why you group classes together. Why you group methods together. And the application maybe is the higher description of the package, of the Smalltalk package that we call applications. Then, while this is simple one, it's just protocols and categories. We try to correctly classify our methods in nice categories. This is nothing new. We run lint check-ins. So we run lint. We try to make sure that we are not missing some potential bug. And the idea here is just to try to improve the code quality. Again, it's, as you can probably guess. We run test coverage analysis, which help us to build confidence of what we develop is actually working as expected. It can give you a possible measure of how effective your test suite is. You know this saying that if the code didn't get exercised, it should assume broken, right? So that's why we try to test coverage as much as possible. And the last one is profiling, because we understand that the BAS platform is at the very bottom of the technology stack of our customer, so therefore it should be as efficient as possible. So that was more or less about the coding aspect. It was the longest one, so the next one will be shorter, so don't worry. So now in the test area, and this one is challenging. The first thing is that we have multiple type of tests. As I showed you earlier, we have a S-unit test suite of very extensive, of I think 20,000 class or something like that. But we also have virtual machine tests. We have what we call installation verification test, which basically we run the installers, the Windows installer and the Linux installer, and we test that all of the files were written in the correct location with the given permission and things like that. And eventually some manual human-driven test for whatever reason it might still be necessary. So we have all of those multiple type of tests. Then we have multiple platforms. So, for example, we support Windows and Linux. We have different CPU architectures like Intel x86, 64, ARM 32 bits, ARM 64. We have different support for different type of screens like high DPI and non-high DPI, with even different scaling factors. We have been beaten by edge cases of high DPI issues that happen only with a certain scaling factor. So then we have Linux variations, like we need to support Linuxes with dev installers, with RPM, Linux desktop, Linux server, KDE, Genome, and all of the different graphical user interfaces that Linux has. Windows variations as well, like we support Windows Server, Windows Desktop. So a lot of different platforms that we need to support. To make it even more challenging from the testing perspective, VAST can also be installed differently. So you can install just the client or the manager or standalone, which means both of the previous ones. So depending on what you install, it will install different things. So it's a different path, let's say. And then finally, we have two types of Smalltalk images in VAST. We have a very basic basic image, and then we have the normal, a little bit bigger development image, which is what most people use. So, in summary, we have so many combinations that we need to test, because we have multiple types of tests, multiple platforms, multiple installer options, and two types of images. So that makes testing a really challenge. And we have a nice CI infrastructure, which I can talk later. If someone wants to know more about that, about the details, I can explain. But it will take me like a whole another presentation to do so. Now, getting into the build moment. So, as you can imagine, we do regular builds of the product. The build basically means we grab what the different engineers have been submitting, and we need to take the previous build and apply potentially new VM, new files, and we build basically the Smalltalk images, all of the installers, what we call the runtime support files, which is basically a set of files that our customer need to run in production their Smalltalk images. So that's about the building, but we also take the opportunity when we build to also run the test. So we have the IVT, the installation verification test that we run. We run the S-unit test. We also run benchmarks on every build. We can compare with previous builds to see if in a given, in the new build, if we either got slower or faster. So we are always monitoring that on every build. Okay? Then about documentation, and we are getting to the end here. Something which I think it's nice is that we have all of the VAST versions documented. So for each, so let's say you take VAST 8.6.3, you will find the documentation for 8.6.3. If you are using VAST 13, you will have the documentation for VAST 13. So I think that's pretty cool. Then we also have, and this is fairly new, we kind of trying to auto-generate documentation from the comments in the code, the type of comment that I showed earlier. And finally, the migration guide, which I think is critical. As I explained earlier, we need to give our customers an easy upgrade path. The migration guide basically contains, if there is a change that would require a customer action, we document that there. So we said, this was the change, this was the reason of the change, and this is what you might need to do. And we do that for every type of change that requires that. So then when our customers upgrade, they go to the migration guide and they say, okay, what do I need to do to migrate to the new version? And there is a full, and to be honest, we try to minimize the amount of changes. So generally speaking, it's fairly easy for our customers to migrate. And funny fact is that the migration guide dates back to IBM Visual Edge 3.0 from 1995. So you have all of the upgrades until the very latest release. Okay, the conclusion. I've been talking for about 20 minutes. So why I'm talking about this? What is the reason? Why does this really matter? And I think that, and someone said this before at ESUG, I don't remember who said that, but the software doesn't live alone. It must evolve and move forward to effectively evolve alongside all of the rest of the systems and platforms that surround VAST. So we need to evolve together. And I hope that with this presentation you could get an idea of what we call responsible evolution, which is the top priority at the VAST team, which is, again, as I say just next, the responsible evolution is that balance that I talked during the talk that has allowed our customers to keep pace to the inevitable changes of technology, while also being able to count on the stability of a commercial Smalltalk system like VAST. And that's it. And that's all I wanted to share. If you have any questions, I will be happy to answer. If you have questions later, we have the rest of the day. So, oops, this again. Yeah.
I have a couple of questions. First, can you say a word about code coverage?
Yeah. So we have a tool like most of the dialects that you have two ways to do it, but the most common one is we say what apps we want to watch. Say, okay, watch, I want to monitor these apps, and then you run the test, and basically it gives you a percentage which you can drill down from the app to the different classes.
But the approach is to wrap methods or something
Yeah,
like that. Okay.
yeah, exactly.
All right.
Yeah.
And the other one is related to tests, to unit tests in particular. How long does it take to run all the tests? And in the second place, if you have some policy in place to write tests, meaning that on a per issue base, or what's the general policy you have for writing tests?
Yeah, that's a good question. So the first one, the whole SUnit suite with the 20,000, that takes about half an hour or something like that, or 20 minutes. I don't know. It takes quite some minutes. Usually, we let the CI run that for us. Eventually, each developer may run the whole thing when you are about to submit code changes to the trunk. But most of the time, we just run what we think, except it was a change in the very low level, we try to just run the test for that and leave the CI run the whole test suite. And the other question is, yes, if we got a bug, we do create a test for that bug. That's one of the options. The other one is when we are building something new, or we are refactoring. So if we are refactoring something and we realize that there are no tests for that, we try to write a test. If we are making something from scratch, like a new library, that will have tests. So that's more or less the policy.
Thank you.
You're welcome. Yeah.
If someone wants to put some malicious code into your VM or image, how can he do that?
A developer, you mean?
Pardon?
Sorry, who wants to do that?
Someone. So my question is more how you prevent it from the security perspective, the building process of the platform.
Only us can access the.
But you probably have some dependency libraries and.
Okay. The only dependency that I am aware that we have, it's the libc, obviously. That's at the and Rust. Then we also Scintilla, the Scintilla editor, which normally we do not upgrade immediately. So we usually wait quite some time for those tools before we upgrade those. And then we have, for example, OpenSSL, but we don't ship the DLL ourselves. So I don't think there are much external dependencies except libc. I don't know if you guys think there is something else. Okay, go.
Hello, I'm the primary VM engineer at Associations. We got some third-party libraries included into our VM, as what Mariana mentioned. We depend on libc and for Linux, of course. And it is Scintilla. Also, we provide some third-party compression libraries, like broadly. And also we use internally libffi and LLVM, as it is a core power for our virtual machine. And we do a review of updating the core parts like libffi, but what we do, we also contribute to that libraries. Like I found a couple of bugs in libffi, so they accepted my my proposals. And also we recently found a bug in LLVM itself, so we also reported it, and it got really got fixed really fast.
A very quick question. Do you have any mechanisms to inform your users that code has been deprecated, that you would like them to use a different technique, but you're supporting this for now?
Yes, we have a deprecated mechanism inside the image, mostly at the method level, where you could say deprecated in version X, use this instead. We give a couple of, we don't remove it immediately. We give a couple of releases before actually removing that.
Perfect. Thank you very much.
You're welcome.
Thank you. I guess you're working mostly with local repositories, each of you. So do you have some mechanism for exchanging code between those repositories? How do you synchronize with one central one? Is it Git already, or what are you using there?
That's a good question. So internally, each of us uses its own manager, the MB manager. So we connect locally, and we have one central repository where each developer connects to submit code. And then that repository is the repository that is used to run the build process. So basically the build process takes the submissions from that repository and makes the build. Now, how do we move the code from our local MB manager to the remote MB manager? We have a few ways to do it. One is just manually exporting into a .dat file and import it in the remote manager. That's more a manual process. But we have a little tool that we hope we can make it, we need to improve it a little bit, but there is a tool that we use internally that allows you to connect to a remote MB server and move things around from the two managers. So that's a much easier way to move code between two. Yeah. We are planning to do that potentially available to customers, but it's still not there. It's not production ready.
Thank you.
You're welcome.
Thank you for your presentation.
Okay, thank you.